Hello, dear students. Today we have Proposition 15 of Book 3. Of straight lines in a circle, the diameter, the line going totally through the center, touching the side, the diameter is the greatest, and of the rest of the lines nearer to the diameter are always greater than the lines more remote from the diameter. Okay? Now, I'm going to do this in more ways than one, just to make sure, okay? I don't think, at least in the book I have it, I only did it one way. I'm going to do it where they fall on separate sides, and I'm going to do it where they cut each other. I'll explain that later. Okay, so let this be our circle, and let this be three lines, one being a diameter, the black line being the diameter, the red line being a line closer to the diameter than the green line. The green line is further away, it's given, is further away from the diameter than the red line. Thus, it is required to show that this line, the diameter, is the greatest. The nearer to the diameter is greater than the more remote. The red line will be is greater than the green line, okay? So let's start by dropping perpendiculars, a perpendicular to this more remote line, okay? From the center, drop a perpendicular, okay? And this line will be further away. Okay, so let's go, what do we want to do here? Let's cut from the greater, so let's go ahead and drop a perpendicular here just to make sure. Let's cut from the greater, this being greater than this because, this being greater than this because this is closer to this than this is to this, okay? Sorry, this is closer to this than this is to this. We know that it's the perpendicular dropped from the center to that circle that measures the distance. If this is granted that it's be further away, the perpendicular drop is longer. So let's cut from the greater a line equal to the lesser, okay? And now let's make from that point of cut, that cutting point, let's draw a line perpendicular to that line. And that's connected to the other side. Okay, so just I'm going to distinguish it from this other red line, so I'll make it dashed. Okay? So, let's connect some lines here. Let's connect here to the center, drop lines to the center. From the point of contact. And then from this point of contact, drop lines again to the center. Okay? So, we'll look at this later, but look at these two triangles, the green triangle and the red triangle. And this is the center, so this and this and this and this and this and this are all radii of this circle, so they're all equal to each other, okay? So I got this being equal to this, and this being equal to this. That is to say, this and this are equal to this and this. That is to say, this whole line is equal to these two dashed red lines. Now look at this red triangle. In any triangle, two sides are always greater than the remainder. So these two dashed red lines are greater than this line right here. But this black line, the diameter was proven equal to these two dashed red lines. So this black line is also greater than this red line. But this red line is equally distant from the center to this red line because we cut this equal to this and it's perpendicular. So these are the perpendiculars falling from the center and they're equal. So these lines must be equally distant from the center by definition. That's what you mean by, that's how you show that's how you talk about lines being further away from the center or not. So this black line, the diameter was proven greater than this line, and this line is equal to this line. So this black line is also greater than this line, okay? So we got the diameter being greater than the line. Now let's show that this line, that is to say this line, is greater than this line. That's easy. We have the green triangle and the red triangle, okay? And we have two sides being equal to two sides because all those sides are radii. So Let's go here. Okay. So these two red lines contain a greater angle than these two green lines. Okay, see that little angle? So here you have two triangles with two sides equal to two sides, and one of those sets of two sides encloses a greater angle than the other. And we know from a previous prop, therefore, that the line subtending the greater angle will be greater than the line subtending the lesser angle of those two triangles. That is to say, the one with the greater angle will have a greater base. So this is greater than this. But this is equal to this. So this is also greater than this. So therefore, we have seen that in a circle of lines in a circle, the line going through the diameter will always be greater than the others. So no matter how close this is, you can do the same proposition to show that the diameter is greater. And of the rest, that the lines falling closer to the diameter are always greater than the lines falling more remote from the diameter. Okay? I just want to do this one time if the lines are crossed. Okay, let's say the two lines you find are on the same side and they even cross each other and make it even more complicated. So let's do this here. Let's drop, but it's given that this is more remote than this. If I'm using the same color, this was given to be more remote than this. So here we have this being more remote than this. Great, let's go and do this exact same thing. Drop a perpendicular to the more remote, and then just go ahead and connect a line over here. Cut from the greater a line equal to the lesser. Say, something like that. And then draw a line perpendicular to that line. Say. Okay. And then cut from the greater a line equal to the other perpendicular drop to the red line. Okay? And cut from the greater a line equal to the lesser. We know that this is less than this because this is more remote. So cut from the greater a line equal to the lesser. Cut it. And then draw a line perpendicular. Okay? So because these have equal perpendiculars, this dashed red line is equal to the red line, this dashed green line is equal to the green line. So whatever you prove about these will be true about these, okay? So now let's make some connections here. I'm going to do it just like we did over here. I'm not going to do the whole prop, but just to give you an idea. Okay? So you prove in the same way that this is greater than this because this and this are greater than this. Therefore, this is greater than this. Then you prove that this is greater than this. Why? Because same thing, red triangle, green triangle, two sides equal to two sides, one of them containing a greater angle, therefore the base being greater than the other base. But this base equals this, and this base equals this. So therefore, we have shown when they cut each other that the line to the diameter, the line to the center, the diameter will be the greatest. The one closer to the diameter will be greater than the one more remote. Okay? Cool. Therefore, we have shown that in a circle, of lines in a circle, that the diameter is the greatest. And of the other lines, the lines closer to the diameter are always greater than the more remote from the diameter. Quod erat demonstrandum. Thank you. Bye-bye.